Video number 2. So hopefully you've got an introductory set of notes about why the anaerobic glycolysis system becomes the dominant system in high intensity exercise, the fact that it's the breakdown of glucose or the stored glycogen which comes from our carbohydrates, the fact that it is good for high intensity, it's pretty quick, but there is no oxygen present, and at the end of the day lactic acid is produced which fatigues our muscles. That's the important part from video 1. Video 2, here we go. What we actually need to look at, and I'll put it down the bottom so it makes a lot of sense when we get to the end of this, is that we have had an ATP inside our muscle. We've moved the muscle. So that ATP has become ADP and that inorganic phosphate over there. And what we want to do is make ADP and P back to ATP again. The one thing that came out of that was the energy. So what we want to do is we want to put energy back into that equation. We want to put energy back into that equation. Apologies, my last video just finished finalizing. The way that this works is very simple. We actually start off with the best case scenario, and that is that we have some glucose in the bloodstream, because remember, when you've consumed carbohydrates, they are transported as glucose. So they've gone through the metabolizing process in the stomach and they've become glucose. Glucose is the form that carbohydrates are in the body when they're good to be used in the glycolysis process. And remember, we're talking about anaerobic glycolysis here. So if we have glucose in the bloodstream swimming past the muscle that needs it, the muscle will grab that glucose out and it will go through a process. And that process has a name that you already know, and that is glycolysis. And through that glycolysis process, we actually produce energy. And the energy that is produced through the glycolysis process, the breakdown of glucose, is used to put ADP and P back together, which makes ADP and P ATP again, and we can make that ATP back into ADP and P by using the energy to move a muscle. So as long as we've got glucose in our body and the glucose can go through the glycolysis process, we can continue to resynthesize or put ATP back together. And it happens relatively quickly. However, this is the difference that happens with the fact that this is the anaerobic glycolysis system. When glucose goes through its glycolysis process, that's not the end of the line. The glucose has to be left as something. And what it's left as is called pyruvic acid. Very hard to write on this board sideways, I do apologise. Pyruvic acid. Pyruvic acid might sound a little bit fierce because it's got the word acid in it, and we've just said that lactic acid is a bad thing. But pyruvic acid is not a bad or a good thing, really. It's sort of a midway point for this system. And because we've said that this is the anaerobic glycolysis system, the question is asked, do I have enough oxygen at this point? The answer at the moment is no. That muscle, that calf muscle, that quadricep, that hamstring doesn't. And so the pyruvic acid has to break down further. And what it becomes is two things. It becomes lactate and hydrogen ions, which its symbol is a H with a plus above it. Hydrogen, Hydrogen, ions, IONS. When we look at lactate and hydrogen ions, those two things together are referred to as lactic acid, and they are the things that fatigue our muscle. So let me repeat myself right now. Glucose, swimming by in the bloodstream, grabbed out by the muscle, goes through a glycolysis process and produces energy to put ATP back together. We keep using that ATP, great. But that glucose, after its glycolysis process, is left as this midway thing called pyruvic acid. And pyruvic acid asks, is there enough oxygen in this muscle? And if the answer is no, then the pyruvic acid has to become lactate and hydrogen ions. And lactate and hydrogen ions are known as lactic acid, and they fatigue our muscle. One final thing I'll add to this diagram is that if there's not enough of that glucose in the bloodstream that I keep talking about, and we've got some glycogen sitting stored in the muscle, that glycogen actually needs to go through a process of its own in becoming glucose again. And in that process, it just takes a little bit more time, because the only way we can go through the anaerobic glycolysis phase is that it's actually using glucose, not glycogen. I'm going to create another video in a moment where I talk about lactic acid, because that's the main byproduct of this system. But I would like you to draw this diagram, and hopefully you can understand how this diagram comes to part.